right, so this is a root example, which more than likely with a root example, what's going to happen here is one of our weird things is going to happen. Either I'm going to get a vertical tangent case or a corner case. All right, find the absolute max, absolute min over the integral. And this function exists everywhere, so it's continuous and smooth everywhere. So I will be guaranteed a maximum and a minimum somewhere between the closed interval 0 to 3. All right, so first step, find any critical values. Again, only between 0 and 3. So find the derivative, and this one will actually have a 0 case and a does not exist case. All right, take the derivative. This is going to require the chain rule. So the first thing I do is pull out the power 2/3, 8 minus x squared raised to a negative 1/3, but I'm not done yet. Chain, which means the inside, derivative of the inside is a negative 2x. I am going to rewrite that because I want to have a numerator-denominator kind of thing. In the numerator, this 2 stays, this negative 2x stays, so I get a negative 4x up top. Denominator, the 3 stays. And that 8 minus x squared moves down there with it. 8 minus x squared, when it moves down, it becomes a positive 1/3. That's important because I'm going to get 2 different types of critical values. I'm going to get a 0 critical value and a does not exist critical value. Numerator, denominator. It's a 0 in the numerator, 0 in the denominator. So 0 in the numerator, well, 4x is 0 only when x is 0, so I have a critical value at 0, which 0 is my endpoint, so it's a part of my answer. Does not exist when the denominator 8 minus x squared equals 0, so this one I have to do a little work. I'm going to move my x squared to the other side, take the square root. And so I get 2 critical, and there are 2 critical values, one at and again, if you want to rationalize that as 2 root 2, fine. I actually think it's easier to leave it root 8 to plug it in the calculator and the function. I'm going to leave mine root 8. I only want the positive. The negative does not land in my domain. Remember, my domain is just the positive numbers from 0 to 3. Square root of 8 is about 2.4, I believe. I know, 2.8, something like that. And you check it, it comes out, it's between 0 and 3. It's a little bit smaller than 3. It's 2 point something. And so the 2 critical values I want to keep are those. Those are the critical values that I'm keeping. All right, so remember the test. The test is, well, somewhere between 0 and 3, I get a maximum. So I want to find the y value. I take the y value at the endpoint 0 and at the endpoint 3. And then the one critical value that I found between those endpoints. So the square root of 8, the positive square root of 8. All right, so again, they're plugging into this function. All right, so when I plug 0 in, I get 4 out. When I plug 3 in, I get 1 out. And when I plug the square root of 8 in, I get 0 out. All right, which tells me this is my minimum, this is my maximum. All right, so over the interval 0 to 3, 0 to 3, g of x has an absolute max of 4 found at the 0, right? My 4 was found at the 0. And an absolute min of 0, it's the y value 0, found at the positive square root of 8. All right, so there's my answers, right? That's my answer. Now to go to the graph to check my answers, to make sure that I did it all right. So the graph is the check step. All right, so now I'm going to look at my graph to check it. Again, I'm graphing the original function g of x, which I'm going to pop my graphing calculator. I already have it typed in. So there's my original function, 8 minus x squared, parentheses, raised to the power 2/3, the fractional power 2/3. I did adjust my window a little bit. Remember, I only want things between 0 and 3. I like to go a little bit beyond that, so I went -5 to 5. All right, and I actually did -5 to 5 in both directions, just to keep the window square. All right, and so when I go to the graph, again, I don't want the entire thing that I've got graphed here. I'm only interested in from 0, at the origin, 0, to the x value 3. And so 0, I'm up here at 4. Right, I don't need to plug that in. I can actually see it. And then when I hit second trace 3, second trace value 3. There we go. Enter. It puts me there. All right, so there's my 3, 1, and then that would be at my square root of 8, right? You can check it out. If you type in second trace value, square root of 8, it should give you 0. All right, so now I'm going to go graph this. Again, only the piece that I want. So when I go back to my notes, there we go. When I graph from 1, I keep wanting to do 1, from 0, sometimes it doesn't like to go back to the notes. Come on. All right, so again, I'm only graphing g of x from 0 to 3. That's the only piece that I want. And so when I do that, my 0 was up here at 4. That's where I start. Came down, hit the axes at the square root of 8, 0. And then a little bit above that, not much, at 3, 1. So again, there's a corner here and then a curve. And so it should make sense that the derivative didn't exist there. Negative 8. This is my min. This is my max. So my answer does check. The minimum value is 0. The maximum value is 4. Between 0 and 3. All right, I believe that's the last of the closed cases. All right, so I believe my next examples are going to be open cases. So the other principle, the open principle, which is the concavity test. And so those will be my next examples. All right, stop there. I'll pick those up in the next